For the inaugural Rubber Duck Engineering, where we have no idea what we're doing. I'm Eric Seidel.
I'm Adam Barth.
And what are we going to do today, Adam?
Whatever you want. We talked about doing a graphic equalizer.
Yeah, I think that'd be fun. So we're going to take some sound and we're going to figure out how to make some pictures out of it.
Yeah, I was thinking maybe, I don't know, we could get your guitar hooked up as like the input.
Oh, that's a whole nother level.
That might be ambitious for the first episode. We could start with something simpler, like creating the repository.
Yeah, I think we could maybe create the repository. So are you driving this train or am I?
Go for it.
Okay, let me find a terminal of great justice. And I think I probably need a GitHub page. I didn't think to do this.
Do you want to share your screen so the audience can see what you're up to?
Yeah, let me share my screen. Okay, I have a terminal. Oops, where'd it go?
This is a professional live stream, ladies and gentlemen.
Let's try this time with feeling. Okay. So let's Rubber Duck. Yes, correct my typos, please. I have two monitors, so when I'm not looking at you, I'm looking at the code. I apologize.
Okay, I won't be insulted.
Okay. So, and, well, we don't have to push it to GitHub yet. I can deal with that later. But what are we going to do in this thing? Maybe we should put some pixels on the screen?
Yeah, I mean, do we want to make like a desktop app or a mobile app, or what are we doing here?
Well, you know that you and I have a cheating answer to this, which is I think we should just use a system that allows us to go to all of the above.
Oh, okay.
At least that's what I know how to type in. So what I'm referring to is Flutter, which Adam and I both worked on in our long history together, and we can create a Flutter app. Which I've installed Flutter. You can see the instructions on the website. Create, I don't know how to spell equalizer, so we'll call it sound. It's not without embarrassing myself. So I think I had the secret macOS version turned on, or maybe not so secret, but non-stable Mac and non-stable web turned on. So that includes both of these, and we can work on the Mac copy.
So we're on the leading edge, huh?
We are on the leading edge. All right, so how are we going to start here? We need like a sound. We need to get some data out of it. So let's step back and what are we actually looking at doing here? So Adam and I were riffing off stage. We were talking about things that we might want to build, and one of them that came up is that I've never actually built an equalizer. One of those things that shows the little levels of the sound. I know it's possible. I suspect it's like a CS, something programming project, but I've never done it in my career. So I think it'd be fun.
Yeah, so I think it's got a bunch of pieces to it, right? So you got to get the sound in. You got to do like the fast Fourier transform on it, and then you need to have like a graphical output for it. So maybe we should tackle one of those things this episode and sort of build up over time and try to get it all put together eventually.
Yeah, I think the thing that's most interesting to me is the the Fourier transform applied on the sound. I think like getting it in and playing in all this relatively boring plumbing. Obviously, it has to be done. Let's see. I guess the way that I typically start is, well, first of all, I just open the code. I actually didn't want to open the whole directory, so let's go back. It won't matter, but let's open up sound here. So if we open up Visual Studio Code, which I already turned the font size up so you guys have some prayer of seeing. I think I tend to start by just writing out the notes of what I'm going to build.
Mm-hmm.
We'll do it in the README. So we need to somehow get the sound. we need to decompress it. We need to
transform it, right?
Yeah. So and what is it that an equalizer is actually showing?
So I think it's showing the frequencies in the sound. So I mean, we could do one to start with that just showed the actual sound wave that was coming in, but a classical equalizer is showing you like the different frequencies. And that's why I thought it'd be cool to hook up the guitar, because the guitar, you should have like the harmonics should come up as like different peaks.
Okay. Well, I have all that equipment. None of it's set up. So I think that's maybe we could show it next episode kind of thing. Or maybe I can grub around. Okay, so getting the sound, we're going to start from a recording today. Are there sound formats that like don't require any fancy decoding, or do we have to like depend on FFmpeg?
Well, there's Wave, which is a pretty direct encoding of the sound.
Okay.
But I mean, I think we should just look for a package that can read in a sound file. I don't know if there is one, but
okay, we can do that, and then decompress it. This is just, what does it then turn into? Like, what does a packet of sound look like?
I think they're different formats, but like commonly it'll just be a sequence of samples, where each sample will tell you like how, like where on the waveform that particular sample is, and then I kind of imagine that. I don't know. I guess maybe we should try to start with the reading the sound in, and then we'll find out what format it gives it to us in, and then we can see what we can do with it.
Okay. Okay, and then transform it. And we're trying to like bucket it into frequency buckets, or you said there were other ways that we might transform it.
Yeah, so we'll have to look up how to do a fast Fourier transform. But I think what happens is you take like a snippet, like a certain number of milliseconds, and then you apply some algorithm to it, and you get out a frequency, like how much power is in each frequency.
Okay, seems reasonable. And then display it. We'll write some code to push the pixels. That's the easy part.
Yeah, I think this part could get really fun. We could get really creative with what it looks like.
Okay, so I think the first thing we have to do is we have to do a little bit of like searching, both to like get a sound and like figure out a package, right?
Yep.
So let me figure out how to get a web browser onto the screen. Okay, so sorry, learning to navigate. Okay, here is a web browser. Okay, so we want like, the system we're using is Flutter. The way that they store their packages, or that we store our packages, because I work on the Flutter team, is pub.dev. And so we could do sound input.
We search for like MP3 or
3 chord.
Do you want to up the font size a little bit? I think it would make it easier for people to see.
Yeah.
Yeah, it looks good.
How's that?
It looks great.
Great. Okay. Sound.
Oh, that looks pretty good. Sound stream.
Streaming audio data from a mic to an audio engine without using a file. Okay. You can see what it does. Stream of data from a mic. Okay. Raw sound data. Okay. Support both Android and iOS, yeah. Probably doesn't support Mac.
I see. So maybe we should start with a sound file. Maybe we'll go to this one too, like TechUp.
Yeah, that is a problem with using like a non-stable system, like running Flutter on a Mac directly. We also could just run inside the iOS emulator. But let's go back and see. How do I go back?
Try backspace.
Doesn't seem to work. Sorry, web browsers are hard. Only I'd worked on them for longer. Okay, let's go back. Let's see what we got. Sound stream that relates to sound like audio recorder sounds. Oh, that's Android and iOS.
Oh, playing short audio files.
Is Wave simple enough that we could just open it like a file?
Yeah, for sure. You want to try to write a parser for Wave?
Well, let's just see if there is one, first of all. I mean, that's not a terrible idea. It could be kind of fun.
I can go research on my screen and parallelize this.
Yeah. We may also be able to show both of our screens. It's not just me reading the internet. A Flutter plugin for audio playback.
I think just write a parser for Wave. I think that could be fun.
Yeah, I think that sounds like a lot of fun. Great, let's do it. All right, so we have to figure out like what the Wave file format is.
Mm-hmm.
PD to the rescue. Or this add. Say riff.
I think Wave is just a riff container.
And riff is another.
Yeah, riff is like it's a very common container format for media files.
Okay, chunk ID, chunk size, format, subchunk ID. I mean, we also could just depend on something like FFmpeg, but then we have to like wire it into Dart. We could also use a different language. I think we're okay where we are. We just. So I presume there's just a header and then there's just like a long array of chunks.
Mm-hmm. Yeah, if you look at the Wikipedia article, if you go to WAV on Wikipedia. So if you, Yep.
Okay.
Yeah, so you look down where it says Riff Wave. Again, you may want to make your font size a little bigger.
Character tag and the size, number of bytes of the chunk.
Mm-hmm.
Okay. The outermost chunk of a riff file has a riff form tag.
Yep. Yeah, so we should start with a riff decoder, and then looks like Wave is built using that.
Okay, so let's like get a Wave file.
Yep. You can open it up in like a hex editor, see what it's all about.
Yes, I think I even have one installed. Obviously, there's a command line too. Let's see. Free Wave file. I have no idea what this is.
It's going to be very dangerous to play on stream.
Yeah. I have no. Maybe this is something that you could research off camera.
Okay.
Then how you would get it to me, I don't know.
I could check it into the repo.
Are you able to make a repo?
I think so. Do you want me to create a repository for this stuff?
Yes.
Okay.
And then I can check it out. Okay. Sample Wave file. Yes, these seem these.
Okay, I created a repository in the RubberDuck-Eng GitHub called Sound. You should be able to check out.
Okay, can do. Let's see, it's going to be sound. I should actually just be able to set that as my origin. Get remote. I see. I haven't get init here. Net, okay, git add remote. I remembered the format. I'll just pull it up on GitHub. All right. GitHub.com. And we're rubber duck eng. Ah, you did. A graphic equalizer. Thank you.
Okay, I've got an example wave file, so let me put it in the repository.
I'm just going to check this sucker out. Here, let's make it so that our viewing friends at home can see. So, okay, so I went to our repository here. I'm going to grab the code. Since we just created this as a template, I'm just going to actually remove it and git clone. Okay, we got it. So now I can Flutter create. I want to see, Flutter has this option to not add comments, I think, in the template.
All right, I've just pushed a commit that has the example wave file.
Great. Flutter create. I'm just going to create a Flutter package or Flutter inside this. Make my terminal a little bit bigger so folks at home can follow along. We had said this would be a hot mess.
Yeah, that's the fun of it, you know.
No, actually, I mean, I have no idea what it looks like at home, but nothing's blown up yet. Clearly, we should be using more explosives.
That'll be in episode 2.
Okay. So, git commit. I'm gonna Flutter example. Flutter template. I see. I have to add all that stuff. Let's pull first before I add all this stuff. Okay. Git add star. Git add. Let's see. What did I successfully add? Okay, I added it all. Git commit Flutter template. Okay. Hi, I've committed. You personally created this key. Has blocked SSH keys created by some third party. Your query was created.
That's interesting.
Fascinating.
We should push through that offline.
Yeah, I don't think anyone can do anything with this information, so I'm not worried about it from a security perspective. But yes, I can deal with that later. I'm going to pull this URL so that I can I see. Okay, so when I read the actual website, it's just saying that because I created my GitHub key eons ago, GitHub didn't have all the audit information or whatever for that key, and so it by default blocked it. I have now authorized the key, and I can now push like normal.
Oh, great.
Okay, so you and I both have the key. We've now opened this. Oh, did I open it again? I see. I lost these edits, but that's fine. It saved me. So I've copied the edits and I'm pasting them back down. Okay. And now let's look at the sounds that you got. You put them in examples. Great. All right, so I think the first task is to just open the file.
Okay.
I think I might even start with the command line before we even get to pixels, just because we can.
That's a good idea.
So we actually don't need this per se. I can just add a new file, which is simple.dart. All right, so that's not how you say main in Dart. Oh, it is. All right, so let's make sure this works.
The venerable hello world.
Hello interwebs. See if I actually know how to code it all here. Dart lib simple.
Oh,
Warning,
great.
interpreting this package as a URI. Okay, I don't know what that means, but it looks like it worked. Okay, so next thing we need to do is we need to actually open the file, which I think requires import Dart.io. We could go look up on the internet how you open a file in Dart. I actually think I might need to do that. Forget. File Dart. So it's the FileCast class in Dart.io.
Mm-hmm.
And we don't want to read it as a string. We want to read it as binary. How does it feel staring
Being a
over
rubber
my
duck?
shoulder?
It's
What
great.
do you say?
I thought you were going to say, how does it feel being the rubber duck? And I said, it feels great.
Yeah. I mean, that maybe we should talk a little bit where the name comes from, because I'm not sure all would know. Do you want to talk about that, Adam, or do you want me
Yeah,
to?
sure. Yeah, so there's an experience in programming where if you're stuck on something, sometimes it's really hard just sort of sitting at the keyboard to push through it and figure it out. But it's often the case if you have a friend come over and you talk the problem over with your friend, and in the course of actually explaining the problem to them, you actually have an insight that helps you solve the problem. And so often the friend just sits there and plays the role of a rubber duck and like smiles and is a friendly face or a friendly ear.
Yeah. It's amazing how much you can figure out by just trying to justify what you've written and explain yourself. Okay, so this thing, I'm reading it as bytes because I don't need to read. I don't want to read it as a string, because if I read it as a string, that would try and convert. It would try and decode it as though it was text. So I want to see what the return type of this is. I'm going to jump to the definition. It's possible that my setup's a little wonky because, again, I set this computer up to work on Flutter.
You're looking at on my screen here.
Well, as I was typing it, it told me it read.
That's going to give you a uint8 list, which is Dart for basically just a bunch of bytes.
Unsigned int size 8 list.
Mm-hmm.
It is funny how it has such a complicated name.
And it's a lowercase I for maximum confusion.
Oh, good. Really? Huh. Who knew? Why is it yelling at me? Let's look at our problems list here.
Oh, I think you have to import import Dart :typed _ data.
It's also yelling at me about the other half of the project because I never did a pub get. I think if I just go to the pub spec YAML and click on it, there's a way to like get it. There we go. If I just touch the pub spec YAML, it'll actually trigger the pub get, which will make the rest of these errors go away. Like it's telling me the material package doesn't exist.
That's good. That'll help us later.
Which we're not using this code yet. I could comment it all out, but I'm keeping it for now because we're going to want it. We're going to want it later. Okay, so let's go back to our simple Dart. Undefined class. Oh, I see. You said I need import Dart : typed data.
Yep.
I don't think I've ever used that. So I could ignore this and just do var. And it would then infer the type, but I prefer to be explicit here. So let's see what the first byte is. Just sanity. So let's do print bytes 0. Not quite right, is it? I think alt tab. Is that right?
I feel like you need a dollar sign somewhere, but it's been a long time.
There we go. It's been a long time for me too. Although I have been writing some Dart recently. It's been really nice. Clearly not enough.
You should also try to convert it to a character, because I believe the first character is going to be an ASCII character.
Oh, sure, why not? There must be ways to make this IDE help me more. Like I'm doing a lot of typing. So you think bytes dot Dart has a first, or maybe not. Like toString.
I think that'll just give you. I'm not sure what I think that'll just give you the number as a string. I think you want like from charcode.
So I might need to do this separately. Like this is a
string not from charcode is what I think what you want.
What is a uint? Like is uint8 a separate type in Dart?
It is, but it's convertible to int, I believe.
I can just do first. Oh, here I can use var. First byte equals the sucker. And I don't even need these. First byte. And then you think that string that from. I'm sorry, you gave me a thing and I didn't listen well enough.
Yes. So it's a factory, so you're going to need a new. This is a new string dot from charcode.
I don't think you need news anymore from charcode. Yeah.
Oh yeah, that's right. This is like Dart from the future. It's awesome.
Yeah. These days we don't even new anymore. Okay. I don't know what to call this thing, so I called it foo. Okay. Let's. I have stuff here, but I'm going to ignore it for now. And we'll see what happens if I just run it.
Oh yeah, it's totally there. Look at that. It's an 82, which is an R.
So let's look back at our specifications somewhere. Do you remember how to switch tabs?
I believe Control Tab will switch tabs for you.
There we go.
Oh wow, this is a good one. You might want to make this bigger again. This looks beautiful.
So this is telling me, this was documenting the chunk ID. I see.
Yeah, so in every RIF file, the first 4 characters are RIFF. And then I believe it's a length somehow.
Chunk size, 36 plus subchunk 2 size. The rest of the chunk following this number. Oh man. If we wanted to write a really nice wave parser, this could get really complicated quickly. I kind of just want to, you know, suck the stuff out and play with it.
Yeah, why don't you just suck out every field and just print it out, just so we can see what our example file has? Because I believe in Wave it's all fixed size at the top.
I'm sorry, when you say suck out every field.
Yeah, like it says, it has all these byte offsets printed here. Just like read each of those things at their length and then print them out and see what they have.
I see. So 4 bytes, that's each one of these uint8s is a byte. So we're actually going to want, it's an image. Okay. talk me through what you're thinking. My brain is going off into complicated solutions to this.
Oh, just thinking something very simple. So this chart tells you like bytes 0 through 3 are the RIF tag. So we should just pull that off into a variable, and then bytes, whatever it is, 4 through 7 are the size. Pull that off into a variable. Then the next 4 are the format, etc. And we'll just end up with a structure that contains all of the data listed out here in the format, and then we can just try printing that out.
Okay. So why does this not feel like it matches? I see. All right, so this is the stuff that we're pulling.
Mm-hmm.
So we can start by copying this. And then so this is my own maybe quirky style of programming. What you saw me do before when I wrote out in the README, this I would normally just write in comments in the file that I'm hacking on. And here you see me doing it again because I need to do each of these. So what I really want to do is I want to like write a little function that will take a U8 int list and then the various kinds. So like this thing, I want one that I hand a U8 list and it spits out the string.
Yeah, kind of think you want like a class, right? So the class, you're going to give it in its constructor this U8 int list, and it'll have fields for each of these fields.
So what do we think? This is the wave header, something like that. And we think it has string chunk ID.
Yeah, I'll just put all these things in. We may not need all of them in the end, but might as well put them all in for now.
This is an int chunk size.
Yeah, so Eric and I actually have opposite styles of programming. So Eric likes to do top down. No, it's really true. You like to start like this, and I like to do basically bottom up, where I write like the first like little piece of code and then sort of build up from there. But you know, they both work. It's actually really fun to collaborate with Eric because when we work, he'll work top down, and I'll work bottom up, and we'll sort of meet in the middle and have like a thing that kind of works. It's worked in the past.
Back in the early aughts, there was this editor called Hydra that you could like collaborate on the same file. I mean, I guess these days, Google Docs does. Is there a way for like us both to edit the same file, or like can we shard this work somehow?
Yeah, I think that's a plugin for Visual Studio Code. I don't think we should try to dig into that right now, but maybe offline. I think there's a plugin that will let us both hack on the same file.
Okay. Because like it's sort of silly for. I mean, I guess it's good for the viewers at home to be able to see from one screen, but okay. And this format is also a string, we think.
Mm-hmm. Yeah, it's always going to be a wave.
Okay, so
I actually designed a RIF file format once.
Really?
Yeah.
Things I'm learning about you.
So I went deep into RIF. I learned all about it. There's like there's only like 6 things to know, but I learned all 6 of them.
It is some format from the whatever 70s, 80s.
Yeah, it's 90s. Also used for WebP and WebM.
Really?
Yeah, they're both RIF containers.
Huh. Today I learned.
I got to do it because I was working on the content sniffer for Chrome, where Chrome sometimes it's given a file, has to guess like what kind of file is this.
Yeah.
And so for RIF, you have to know to look at. So you look at the first 4 bytes. It says RIF. And you're like, okay. Then you skip the next 4 bytes, which are some incomprehensible number, and then the next 4 bytes actually tell you what the file is.
My limited experience with this, with like file headers like this, is so there's this file tool. It was included in BSD, and when I worked at Apple, and I was responsible for maintaining some tiny, part of the Apple userland in my first internship there. And one of the tools that I committed a couple changes to was the file tool to add like Apple-specific things. And there, all it has all these like regexes or like, oh, okay, I'm going to go look at these codes and guess. It's very similar to what you're describing. It's a content sniffer, basically. So, okay. After the reminiscing. So, okay, so what kind of function do I want here? I want like a, so you think that you just want wave, you want like a wave file.parse kind of thing?
Mm-hmm.
Is that what you're thinking?
Yeah.
Let's call this wave file for now. Okay, and then
Yeah, we just start by just parsing those 3 fields, and then I put like a toString on it or something to like print out the fields in a pretty way.
Make it a constructor. Why not? We can rename it nicely later. Uint. Okay, bytes. Okay, yeah. So now how are we gonna grab, so we wanna do, let's see, bytes. This needlessly makes a copy, but.
Right, so we should look at the string constructors to see what we can feed the string constructor.
Yeah. My jump to definition is not working correctly, so I'll go to the web.
Oh, look at that. It's got, so there's a from char codes with an S that will let you provide an iterable.
Oh, hey, it is working now. It just hadn't indexed, I guess. Okay, so I like it. Chunk, working with modern languages. String that from char codes. Yeah. Oh, it's an iterable of ints.
That's fine. The uint date list.
Work.
Yeah. So I think if you say like bytes dot, you should be able to get a, like an iterator out of that gives you the first 4.
Like sublist is going to copy, isn't it?
You don't want to do sublist. You want to get an iterator out. Let me take a look.
First where? That would get an iterator.
Take maybe, take 4.
Take 4 sounds like it's going to remove it. It's going to modify the list. Is it?
I think it actually just gives you an iterator. I don't think it modifies the list.
Take 4.
Oh, you know what you actually might want to do? Since you're going to parse the whole file, you probably want to create an iterator. And then from that iterator, you'll take 4, and then you'll take the next 4 for the next one.
Oh, yeah.
Do you see what I'm saying?
Yeah, no, exactly. Something to maintain your place in the file. This must actually exist for files themselves. Like, just because I read it into an entire thing, there's probably just a read as bytes. Like an open as bytes.
Okay, so you want to do it directly from the file? That makes sense.
Like, what is open?
Yeah, so like read as bytes. That just gives you the whole thing. Oh, you know what you need? You need a random access file.
So, that's a thing?
Yeah, so in Dart, a file represents basically, you should think of it as an unopened file. And so every operation you do will issue an open, read, close on the underlying file in the operating system. But a random access file
it's a Java thing.
It's in Dart as well. That represents what I would think of as a file handle. So it represents a session with the file that will let you like read little pieces.
Random access file. No joke. Provides random access, yeah. Okay.
Yeah, so read byte will get you 1 byte, but you probably want to read more than 1 byte at a time. Maybe
read into.
Oh yeah, read into is totally what you want. Yeah, so I think you make the buffer of a certain size, and then you call read into on
it. Why do I want a random? I'm sorry, you said that file. I see. File is an unopened file, and so they do the open underneath. Yeah, so you want something that has persistent access, persistent openness. Yeah.
Yeah. So like a lot of these things, you have to understand how the abstraction is built to really understand how to use it. So this thing basically holds a file descriptor, whereas the other thing just holds a path. So every time you operate on the other one, it'll reopen the file.
Yep, like a file handle. And you probably said this, and I was half phased out reading the website. Okay, well, let's try this.
Oh, you know what? You just want to read. Yeah, once you have a random access file, you just want to read. And read, you tell it how many bytes you want to read, and it gives you back.
Nice.
But I think you want read sync, actually. But yeah.
Great. Okay, so we're going to do random access file, Here we go back to var. Let's do the heavy lifting of where all these things are.
So it looks like a random access file, the constructor doesn't take any arguments. You're going to have to call open yourself.
That's fine. Abstract class.
I see. Maybe you get it from a file. Like maybe you start with a file and then you're
They're
like,
called by the open method on the file object.
okay, there we go.
Okay.
Yeah,
Now
there
we've spun ourselves around in circles. Okay. Var open file equals file.open.
You probably open sync.
Sync. Yeah, I mean, there is a question when we deal with this, whatever, we're dealing with small data, we can do everything synchronously for now. We can get rid of our little test code here. And this thing is no longer a uint of bytes. What is open file? It's just a random access file.
Mm-hmm.
Okay. And now we want to do bytes.read, you said? And we want
read sync, I believe.
Oh, you're right, sync.
Yep.
Read sync 4.
And you be able to plumb that directly to string.fromCharCodes.
This is all making so much more sense. I mean, if Dart didn't have these things, it'd be hard to write. Chunk ID. Okay, this is looking better. Okay, and chunk ID, chunk size, and format are all.
I think chunk size is going to be a number.
Yep.
So we're going to have to figure out how to get a number out of an array of bytes.
Are you going to look that up?
I'll start researching, yeah.
That.
It's absolutely do with Indianness.
Here's the other way on Stack Overflow.
Oh, byte data, that's it. Yeah, you want to save as byte data. And the byte data class will let you get your int32 out of it.
And so instead of reading sync,
that's a good question. So let's go see. So read sync.
byte data. This is a byte buffer. View, yeah. Yep, byte data does.
So the question is how to get a byte data out of this.
Well, I wonder if I want to be just working in byte datas anyway.
Byte data is really useful for like parsing things out of type data.
Isn't that what we're doing?
Okay, so excuse me. You want to say so the thing that read sync gives you back has a buffer property,
Mm-hmm.
and then the buffer has an as byte data method. Yep, and that you should be able to get an int32 out of. Right, and now you're gonna want to pass the Indianness because you have to know what Indianness you're. So for those who are not aware, so there are different ways of encoding integers into bytes. You can either encode the least significant byte first in the file or the most significant byte first. It's called the Indianness.
Yep.
So I hope your spec tells you which one it is. Otherwise, we're going to have to guess.
Generally, data on the wire is in big endian. It's last I knew, but let's check. Where did this guy? This one's big endian for that.
Big endian.
Everything's big endian. Oh, the default byte ordering assumed for Wave? What?
Yeah, so Wave is a Windows format originally, I believe, and so the actual data in the file I think is little endian. But I wouldn't be surprised if the header was big endian.
Oh my god. Okay.
Yes.
Okay, well, let's do it. Files written into the beginning. Yeah. Oh, fascinating. Well, we're not supporting that today. Oh,
they changed the riff to riffx. That's really that's a beautiful hack.
Oh, I see. Okay, so these are saying. Okay, so it should be all little endian, is what I'm learning from this.
Oh, even this part here?
Yes. It's just giving you what the header looks like when it's written in big endian.
I see. Because the spec authors, they crack their eggs on the big side, even when they're dealing with a format that cracks its egg on the little side.
I don't know. I have a little, when I used to, on my guitar case, I have a little endian hate eye, or a little sticker. But that was from a different era. Okay, little endian. I mean, all your processors are little endian these days. It's just the network. All the network data was big endian, and processors, Mac processors, were big endian for a long time. It's all so confusing. Okay, shall we try it? Undefined class wave file.
Do you want to put like a toString on it so we can print it back out and see what we got?
You're right. String to string. Let's @override. See if it gives us nice warnings for when I make toString. And we want to return. I'd rather actually just have like a debug print. Makes it easier. So, because I'm lazy. Actually, this isn't very useful in the class itself. It's only ever going to be used once. And I'm not going to have a lot of wave files sticking around. I'm just going to do it here. Let's see, but since when I do that, then I have to do this. Okay. Tell me how would you have written this? Since you start from the opposite end, you said.
I mean, I think you get to the same place. It's just the instinct to like copy and paste the spec into the file.
Is not one you share?
No, I think it's great. I would have done it a different way, but everyone's got their own stuff.
Yeah. Okay.
Oh, look at that.
Amazing.
Amazing.
And is this chunk size about right? Yeah. Because this is that's the whole file.
Oh, so like sanity checks and everything.
Great.
I totally think we should write a test.
We should totally write a test.
Mm-hmm.
We're gonna have to like generate our own fixture though. Like what kind of test are you envisioning here?
I'm just imagining one that read in that exact example file and just checked that those three fields were what they were supposed to be for that file.
Oh, okay, I see. So just using the file as a fixture, fine.
Yeah, we can like tech up later, but it seems like that's a place to start.
That's fine. Okay. So I'm actually gonna rename this sucker because now we know what it is. A little wave parser that we're building here, and this is not a package test. This is like a higher level test, but it's a right-ish format. So actually, it's not the right format at all. That's fine. We'll still make it work. So we don't need any of this. We package sound wave. We don't really need any of this. We need import package test. I think that's right. And we also have to add a dependency here on the pubspec YAML. It can be a dev time dependency. We're not really supposed to depend on any version.
You don't want to research what the latest version of the test package is?
If we just go to pubdev and say we want, this is the way that we actually should do this, not just from my memory. We just look for the test package. Aha, we find the test package. And then in here, it tells us, aha, installing. How do you depend on it? You should use this.
Great.
Okay, I'll use that. That way we don't have to just using Eric's flawed memory here. Okay, so now we're depending on package test.
They may have an example test that you could copy and paste. Which...
I'm absolutely certain you're right. So let's do that. See, we also could have named this podcast the Copy Paste Podcast.
Stack Overflow.podcast.
Because that's pretty accurate about how modern software engineering is done. Okay. All right, so we're going to name the sucker because we're almost actually out of time. So I think we're just sort of...
Yeah, I think we should be able to get the test and run it. And I think it's a really good place to end up at.
Yeah. So what do we have here? This is, we're testing basic wave header. And I find it a little irksome that this is not a self-contained test, that it depends on this random example that we have.
Okay.
But
maybe you should write a to-do comment about that, and we can try to address that.
I agree. To do. It just makes it nicer so that when you or I later be like, oh, why do we need this old example? We don't just break all our tests accidentally, as an example. All right, so.
Yeah, I really think the iterative development process of getting a thing that works in a very simple way and then taking careful notes about what you intended to do and how you might come back and improve it later. It requires some discipline to actually come back and do those things, but.
Yeah, you leave yourself notes. Okay, so chunk ID equals riff, right? I'm doing this from memory. Chunk size, I don't have to do it from memory. Pre-established, my memory doesn't. I think part of the reason why I paste things in is that I just like working from one single buffer, one single screen. It fixes it all for me. Okay, let's look at our problems again. Why? Why don't you see that? Is that because did this thing get named funny? Nope, it's named sound. Did we not? I just saw you do a pub get. Here you're doing another one.
I'm going to try running the test.
All right. I never use terminals inside this, but this actually seems useful to have. Okay. I can do this from the IDE too. Whatever, I'll do it this way. Start test It may also be, again, that I have a funny Dart and Flutter setup because I was working on developing Flutter itself. Method not found. Okay. That seems like a reasonable complaint. I have not imported Dart.io.
Got mad.
Oh,
Oh. Mm-hmm.
typos. What was it called? It's not chunk ID. It was like format. Why is it? I see
Format
it.
ID, maybe? I'll go back and look.
Well, it's the analyzer is confused, or maybe just understandably can't. Yeah, it's format. I will try and de-quirkify my Flutter setup before we next meet. All test pass!
Yay! This is great, Eric. I think we made good progress here.
Yeah, I think we did. And we, nothing blew up. We figured out how to put ourselves live on Twitch TV to our amazing number of viewers. I didn't actually check. I suspect it's small. What do we got here?
We got the sound.
Spec lock. Okay, I think. So I'm just adding all the stuff so that you and the viewers at home can see it. As discussed, I don't plan to touch this between now and when we meet again. And so we'll figure it out all live. We're going to work on towards a standing time. We'll see, find something between your and my schedules.
Mm-hmm.
Move forward. Other things we should discuss?
No, I think this is great.
Most basic wave header parser. Okay, it's live on the internet.
Awesome. Thanks so much, Eric. This is a lot of fun.
Oh, I had fun too, Adam. Thanks for doing this. And I'll see you next week.
See ya.